Alright, today we're going to talk about similar polygons. The objective, I've learned to identify and apply properties of similar polygons to solve problems. We're going to start kind of by defining what similar means. Figures that are similar have the same shape, but not necessarily the same size. Alright, and this little kind of tilde right here, this little wave, that's the symbol for similar. Alright, so we're going to start by looking at two quadrilaterals. And we're going to define similar as two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. All right, so looking at these two shapes, we got to match the angles and make sure that they're congruent. So I would have to say that angle A, is congruent to angle E. Then we would list angle B would be congruent to angle F. Angle C would be congruent to angle G. And angle D would be congruent to angle H. Notice every angle on this side is matched or corresponding to one of the angles on this second shape. And they're all congruent. Okay. The next part, the lengths are proportional. So I take AB and I compare that to the ratio of EF. Okay, that has to equal the ratio of BC to FG, which has to equal the ratio of DC to HG, and then AD over EH. Okay, so if I have four of these angle pairs, they're all congruent, and then I look at the ratio of these four sides, or pairs of sides. Okay, if that ratio is the same, then our conclusion is that ABCD, quadrilateral ABCD, is similar to quadrilateral EFGH. Alright, this first example then. So I'm going to use the figures below to answer the question. So there's that similar symbol. So that tells me I know that angle A would match and correspond to angle X. Side length, or this segment BC, would be similar or proportional to YZ. Angle B would be congruent to angle Y. Side AB would be correspond to side XY. Angle C would be angle Z. And then CA would be ZX. Okay, I'm just matching up the corresponding parts of both triangles. I'm looking at this next example. If the quadrilaterals below are similar, then what must be true about the angles? The angles must be congruent, and the sides must be proportional. Okay, that's just kind of reassuring you or retelling you that similar means that the angles have to be congruent, the corresponding angles have to be congruent, and the corresponding sides have to be proportional. All right, so we got to look at number 3 now, example 3, and determine if the figures are similar. So I got to compare my angles, corresponding angles. So I have a 90 and a 90. Okay, then this angle appears 37. I need to figure out what this one right here is. So if I do 90 plus 37 and plus this x, that has to add up to 180. This is going to give me 127 plus x. So that means x would have to be 53. So this angle right here is 53 degrees. Okay, so these two would match. And then if this is 53, this has to be 37. So those angle pairs match. So I have my 3 pairs of congruent angles. Now I have to see if the sides are proportional. So I want to look at the ratio of 9 to 6. Okay, I'm going to go ahead and reduce that. That's going to give me 3 halves. Then if I look at these two sides, 3 over 2 is 3 over 2. And then I'll look at the hypotenuses. If I have 18 over 12 and I reduce that, That's going to give me 6 over 4 if I factor out 3. And if I divide by 2, that's going to give me 3 halves. So I have 3 halves, 3 halves, 3 halves. So all the sides have the same ratio in simplest form. So then I would say yes, they are proportional. Or actually, sorry, yes, they are similar. The two triangles are similar. All right, something very important to know when talking about similar polygons is this word included. We've talked about included sides and included angles before, just to kind of give you a little refresher. An angle is said to be included between two sides, and a side is said to be included between two angles. Okay, that's going to be important for what we're doing when we're doing these corresponding sides and corresponding angles. All right, so which angle is included between AB and BC? Well, here's AB, here's BC. So the angle that's formed between those two sides, that's angle B. Which side is included between the two angles E and D? So here's E and here's D. This is the side that connects them, so that would be segment ED. Okay, and which angle is included between AE and AB? So here's AE, here's AB. All right, so the angle that's formed with those two is going to be angle A. All right, next we got what's called a similarity ratio. And the similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. All right, so let's look at an example. All right, so I'm going ahead. Here's this similar symbol. So I know these two figures are similar. The similarity ratio is just the ratio between two sides in simplest form. So I'm going to take the 10 and 5, because those would be the two corresponding sides, and then just reduce that in lowest terms. 10 over 5, that's going to be 2 over 1. All right, since it's a ratio, I'm going to leave it as 2 over 1. Okay. All right, now let's look at this next example, 6. All right, quadrilateral EFGH would correspond and be similar to A, B, C, D. Right, because A would match with E, B matches with F, etc. What's their similarity ratio? Well, again, I'm going to pick two sides. I'm going to pick sides that I see some variables here. So I'm going to look at 2.5 and 10, since those are the two sides that don't have variables on them. And we're going from EFG to ABCD. That's going to be important because that tells me that I have to put the 10 on top and the 2.5 at the bottom. Okay, so if I simplify that, that's going to give me a ratio of 4 to 1. So this would be, my ratio would be 4 to 1. And then I'm going to use that to find x, y, and z. So let's start with x. X is to 12. Or let me do it this way, because we're going from EFG to ABCD. I'll do 12 is to x as 4 is to 1. And then we would do our cross products. So this would give me 4x is equal to 12. Divide by 4 gives me x is 3. Okay, same thing with the y now. Y is over here, so I'd say y is to 3 as 4 is to 1. So that would tell me y is equal to 12 using my cross products. And then for z, z is on this side, so 5 is to z, because I'm going from EFGH to ABCD. So 5 is to z as 4 is to 1. Or excuse me, yeah, 5 is to z. So this would tell me 5 is to 4z. And then I would divide by 4. 5 divided by 4. And 5 divided by 4 is going to be 1.25. Right. Now, what's the ratio of the perimeters? the perimeter is actually going to have the same similarity ratio as the corresponding sides. So that's going to be 4 to 1. How do they compare? Well, that's the same. The ratio between B, which is the sides, and the ratio of the perimeter is the same. Actually, that's right. They are equal. All right, I want you to try example number 7 on your own. You can compare your answers or ask me to check them for you when you get this one done. All right, now I want us to look at a different kind of problem. It says the lengths of the sides of a triangle are in the ratio of 3, 5, and 7. Its perimeter is 120. Find the length of the shortest side of the triangle. All right, so we're going to kind of have to create a triangle. All right, and one side has a ratio of 3, 5, and 7. Okay, it says that the perimeter is actually 120 centimeters. So we have to kind of solve an equation here for this. Because obviously if I take 3 plus 5 plus 7, that's not going to give me 120. Right, so what I need to do is that there's some kind of multiple of 3, 5, and 7 that will add up to 120. So we got to figure out what that is. So what I'm going to do then, instead of writing just 3 plus 5 plus 7, I'm going to change this to 3x plus 5x plus 7x and set that equal to 120. Okay, so if I add the x's here, that's going to be 8 and 7. That's going to give me 15x is equal to 120. And then if I divide 120 by 15, that gives me that x is actually equal to 8. All right, but we're not done because I want to find the shortest side. So then I'm going to take the 3x, since that's obviously my shortest part of the ratio. I'm going to do 3 times 8, which gives me 24. So the shortest side is actually going to have a length of 24 units. Okay, and then let's try another one just to kind of give you a different example of the same thing. Same idea. The measure of the angles of a triangle and the ratios 1, 2, and 3. So since we're talking about angles this time, again, I'm going to draw my triangle. I'm going to do 1, 2, and 3. Okay. Obviously, again, like before, if I do 1, 2 plus 3, they have to add up to some number. Since they're angles, they have to add up to 180. All right, but again, 1, 2, and 3, that sum of those 3 is not going to be 180. So we're going to have to look at multiples of those. So that's actually going to be 1x, 2x, and 3x. When I add those up, say that's 3, that's going to give me 6x equals 180. Divided by 6 is going to give me 30. So x is 30, but I want the largest angle, which is going to be this 3x side. So 3 times 30 is going to be 90. So the largest angle is actually 90 degrees.